Today guys, I'm going to be showing you how to integrate the products and powers of both sin x and cos x and the different combinations that go into that and how exactly to approach each one. And I'm going to aim to do this in under 15 minutes. If I don't do it within that time, well, we'll just take it from there. Enjoy the video, guys. Alright, so our first scenario is when k is odd, right? When k is odd. So what do we have to do here? So we've got an example where we've got cos jx, sin kx, okay? In this example, k is odd. So when k is odd, we firstly have to do the following. We're going to say this. We rewrite sine as sin kx equals sine k minus 1x times sin x. Right? The second part is to then go, okay, well, we know that sine squared x is equal to 1 minus cos squared x. Okay, that's the fact we have to recognize, and we're going to use this to then basically implement it into this. Okay, and then using that, we can then use a substitution, because we can say let u equal cos x, okay, which implies that du is going to equal negative sine x dx. So it doesn't really make sense just looking at this, so let's get to an example. Alright guys, so as you can see in this example, k is odd. Okay, so k is odd, so therefore what I say, well, we got the integral of cos the 8x sine the 5x dx, which equals the integral cos 8x sine to the 4x sine x dx. As you can see, right, k minus 1, right, and then sine x. So that's then going to equal what? Well, can equal the integral of cos 8 to the 8x times sine squared x squared. Okay, you see, so we've converted it into sine squared x form, sine x dx. Okay, to which we then say, all right, cos 8x 1 minus cos squared x squared sin x dx. Okay, so what's our third step? Well, third step is to use substitution. So I'll say let u equal cos x. So if u equals cos x, that means that du is going to equal negative sin x, right? So therefore we can say that we've got u to the 8 1 minus u squared, okay, and so sin x dx here, and then therefore sin x dx is going to equal negative du, okay, because we're going to divide by negative, so therefore we've got negative du there. And so what we can say is that the integral is going to equal negative u to the 8 plus 2u10 minus u to the 12 du, okay, which gives me negative 1 over 9 u9 plus 2 over 11 u to the 11 minus 1 over 13 to the 13 plus c. Okay, I would say since u is equal to cos x, okay, what's the final answer going to be? Well, final answer is going to be negative 1 over 9 cos to the 9x plus 2 to the 11 cos to the 11x minus 1 over 13 cos to the 13x plus c. Okay, and that's going to be the final answer to that question. Alright guys, so here we've got the situation where j is odd. Okay, so what do we do here? Well, when j is odd, okay, what we're going to do is we're going to do the opposite of what we did before. We're going to rewrite cos to jx, okay, to cos j minus 1 of x times cos x. That's the first step. Then the second step from that is we're going to use cos squared x. It's going to equal sine 1 minus sine squared x. Okay. So we just use the reverse of the trigonometric equation. Then we just integrate using u is equal to sine x, because we can say du then is equal to cos x dx. Okay, now that you've seen it before, this should make a bit more sense. But regardless, let's get into an example. Right guys, so here we've got the integral of cos to the 3x times sine squared x dx. So what do we do? Well, first thing I'm going to do is going to rewrite this. Okay, and what am I going to rewrite it as? As as j minus 1. So what we've got is cos squared x times cos x times sine squared x dx. Brilliant. Then what do we do? Well, we rewrite this, right? So if we rewrite that, we're going to get 1 minus sine squared x times sine squared x, okay? And then we're going to have cos x dx over here. Okay, I'm setting it up for the next part. If I then go let u equal, sine x, that should be. Therefore, du is equal to cos x dx, right? So, what that means is the following. Well, we get the integral 1 minus u squared, okay, 1 minus u squared times u squared du, right? So we expand it out. U squared minus u to the 4 du, which equals u to the 3 over 3 minus u to the 5 over 5. Okay, so remembering what u is, we're plugging back in, that's going to give us sine to the 3x over 3 minus sine to the 5x 5 plus c. Okay, and those are going to be your final answers. Alright guys, so another scenario is when both are even. Okay, so when both are even, j and k are obviously even. So in this scenario, what we need to do is leverage either sine squared x is equal to 1 minus cos 2x over 2, cos squared x is equal to 1 plus cos 2x over 2, right? And I'll show you exactly what I mean by this just now. Right, so if I demonstrate this with an example, we got sine to the power of 4x here. Right, so we can rewrite that as sine squared x squared dx. Okay, firstly, which tells us what? Well, we can then say, well, okay, what can we rewrite that as? Well, that can be rewritten as a half minus a half cos 2x, right? Based off our last equation. Remember, half 1 minus cos 2x, okay? So, we've got that now, and that's obviously going to be squared. So, next we just go ahead and square it again. We expand it, sorry. So, we're going to have a quarter minus a half cos 2x, right, plus a quarter cos squared 2x dx. Okay, and from here we're then going to say, okay, we just say, well, okay, we've got a quarter, that's a half cos 2x. Okay, if we take out a quarter here now, we can get a half plus a half cos 4x, right? Why is that so? Because we've expanded this bit here, okay, according to our formula before. So from there, we can say, right, we get 3/8 minus a half cos 2x plus 1/8, sorry, of cos 4x dx. Okay, now we just integrate as normal. So that's going to equal 3/8x minus a quarter sine 2x plus 1/32 sine 4x plus c. Okay, and that's going to be your final answer for that question.